Section 3.4 is called the Conditional and Related Statements. We're also doing a short intro to logical fallacies. I want to begin by talking about some equivalent forms of the conditional statement. Every conditional statement can be stated in many equivalent forms. It's not even necessary to state the antecedent before the consequent. In other words, the if part before the then part. For example, the conditional, if I live in Boston, then I must live in Massachusetts, can also be stated as, I must live in Massachusetts if I live in Boston. That's a perfectly equivalent way of stating that conditional. This illustrates the fact that if P, then Q, and Q if P are equivalent ways of writing the same conditional statement. I want to list several logical equivalents to that and sort of give you an example of each. We're not going to go too deep into this, but I do want you to see the breadth. So we start off with if P, then Q. My example sentence is, if you are a citizen of Tuscaloosa, then you are a citizen of Alabama. If P, Q, that leaves out the word then, which is very common in English. So it would be, if you are a citizen of Tuscaloosa, you are a citizen of Alabama. In other words, I'm just leaving out the then. That does not change the basic nature of the sentence, and it's still an equivalent form of the conditional. Another form, Q if P. We talked about that earlier. You are a citizen of Alabama if you are a citizen of Tuscaloosa. That's equivalent to the original conditional. P implies Q. Being a citizen of Tuscaloosa implies that you are a citizen of Alabama. Again, that's equivalent to the original conditional statement. P only if Q. You are a citizen of Tuscaloosa only if you are a citizen of Alabama. Again, logically equivalent to the original. Every P is a Q. The example sentence would be, every citizen of Tuscaloosa is a citizen of Alabama. And Q provided that P. You are a citizen of Alabama provided that you are a citizen of Tuscaloosa. In some of the problems we do, we might need to convert from one of the above statement forms back to its equivalent if-then form. So if you see any of these, you can convert them back to the original first line statement, the if P then Q type. Suppose I ask you to write every parallelogram is a quadrilateral in its equivalent if-then form. What you have to do is look back up at this chart and notice that the next to the last one is every P is a Q. So that tells me that the part about the parallelogram is the P, the part about it being a quadrilateral is a Q. So I can use that and change it back to an if-then form by saying basically if parallelogram then quadrilateral and then putting in a few words to make the sentence flow. So instead of saying if parallelogram then quadrilateral, I'll add words like if the figure is a parallelogram, then it is a quadrilateral. So it's really just that simple. You're going to use that chart to turn the statement back into if P then Q, and if it's necessary to add a few words to make it sound better grammatically, then you can do that as well. Now let's write today is Friday only if yesterday was Thursday in if P then Q form. Looking back at your chart, you can see that the third one from the bottom is the P only if Q. So that tells you that today is Friday is the P part, which is the antecedent, and yesterday was Thursday is the Q part, which is the consequent. So I can convert it back easily into the if P then Q form by saying simply if today is Friday, then yesterday was Thursday. It's a really very straightforward process. Now let's turn our attention to three statements that are closely related to the conditional: the converse, the inverse, and the contrapositive. Every conditional statement of the form P implies Q has three related statements: the converse, the inverse, and the contrapositive. The converse of the statement P implies Q is the statement Q implies P. You're simply switching the antecedent with the consequent. In other words, you're switching the P and the Q. The inverse negates both the P and the Q, but doesn't switch them. And finally, the contrapositive does both. It switches and negates. So if you start off with the statement P implies Q. To find the converse, you switch the P and the Q to get Q implies P. To get the inverse, you don't switch the P and the Q. Instead, you negate both of them to get not P implies not Q. And to get the contrapositive, you do both. You switch the P and the Q, and you negate both. The converse, the inverse, and the contrapositive. Here's an example. What if I ask you to write the converse, inverse, and contrapositive of the statement, if I get the job, then I will rent the apartment. Remember, the converse switches the P and the Q. In the example, I get the job is the P, I will rent the apartment is the Q, so the converse would switch those, putting the Q in the place of the P, and I would get, if I rent the apartment, then I will get the job. That's the converse of the original statement. How about the inverse? The inverse does not switch, but it negates both. So if P is I get the job, the negation would be I don't get the job. And if Q is I will rent the apartment, the negation would be I will not rent the apartment. So the inverse of the original statement, if I get the job, then I will rent the apartment, is if I do not get the job, then I will not rent the apartment. And finally, the contrapositive does both, switches and negates. So instead of, if I get the job, then I will rent the apartment, you switch and negate to get, if I do not rent the apartment, then I will not get the job. That's the converse, the inverse, and the contrapositive. Look at the statement, if I drive you to the mall, then you will buy me ice cream. I drive you to the mall is the P, you will buy me ice cream is a Q. This is a conditional of the form P implies Q. How about, if you buy me ice cream, then I will drive you to the mall. Notice that you switched the P and the Q. Q implies P, then, is the converse of the original statement, P implies Q. Do you think this statement and the converse say the same thing? Read both statements. If I drive you to the mall, then you will buy me ice cream. If you buy me ice cream, then I will drive you to the mall. Although it's possible for a statement's inverse to be both true, it turns out that the converse of a true statement is not necessarily true. Go back to the original statement again. If I drive you to the mall, then you will buy me ice cream. How about this statement? If you won't buy me ice cream, then I won't drive you to the mall. Notice that you've negated both P and Q, and you've switched them. That's the contrapositive. Do you think the statement and the contrapositive say the same thing? Read them both. If I drive you to the mall, then you'll buy me ice cream. If you won't buy me ice cream, then I won't drive you to the mall. My guess is you would say these two statements don't necessarily mean the same thing either, but surprisingly, that is not the case. The contrapositive of the statement is true whenever the original statement is true and false whenever the original statement is false. So this is one of the places where your intuition might lead you wrong, but this is the case. A statement and its contrapositive are equivalent, and we'll use this result in later problems. And if you don't believe the truth of this statement, you can verify it yourself. If you build the truth table for P implies Q and then build the truth table for the contrapositive not Q implies not P, you will see that the truth values are exactly the same. So in summary, a statement is contrapositive or equivalent. A statement is not equivalent to its converse or inverse. Let's try some examples. Are the statements equivalent? If you go, then I stay, and if I don't stay, then you won't go. If you think of this in the symbolic form, if you go, then I stay is of the form P implies Q. If I don't stay, then you won't go is of the form not Q implies not P, which is the contrapositive of the original statement. So yes, these are contrapositive, so they are equivalent. How about this one? Are these statements equivalent? If you go, then I stay, and if I stay, then you go. Well, if you think of that first statement of being of the form P implies Q, the second statement is of the form Q implies P. These are converses. Converses are not equivalent to each other. So the answer is no. If the statements are not converses, inverses, or contrapositives, if you ever come up with that case, you just have to do the truth tables to find out. But if you do get a statement that's contrapositive, you can immediately say they're equivalent. Just for the fun of it, let's go through the truth tables to show that a statement is contrapositive or equivalent. This is sort of just for fun, so I would go through rapidly, but I do feel like it's useful to show that something that's not necessarily intuitive is in fact true. So if you start off with the statement P implies Q, P being the going to the mall thing and Q being the getting ice cream thing, if you go through the original statement, its converse, its inverse, its contrapositive, and build the truth tables for all of them, you'll see if you take the P and change it to not P, you get false, false, true, true. If you take the Q's and change them to not Q's, you'll get false, true, false, true. Then if you do the original statement, remember there's only one case when the P implies Q is false, and that's if the P is true and the Q is false. So for the P implies Q, you get true, false, true, true. If you do the converse, again, I'm going to go through this rapidly, move the Q's over and the P's over. Again, there's only one case where Q implies P is false, and that's when the Q is true and the P is false. In other words, the antecedent is true and the consequent is false. That'd be the third case here. So you would get true, true, false, true for that one. Move to the inverse, do the same sort of things. I'm going to not take this step at a time. You'll get the truth values being true, true, false, true. And finally, if you do the same thing to the contrapositive, you'll find out that the truth values are true, false, true, true. And what you notice is exactly what we said earlier. If you take the truth values for the original statement, P implies Q, you get true, false, true, true. If you look at the contrapositive, what do you get? Same thing, true, false, true, true. So we have just proven beyond a shadow of a doubt that a statement and its contrapositive are logically equivalent. We're going to include a short intro to the topic of logical fallacies. So first of all, what is a logical fallacy? Basically, it's an argument that's not valid. More specifically, a logical fallacy is an argument with an error in logical reasoning. Logical fallacies are like landmines. They are easy to overlook until you find them the hard way. One of the most important parts of college life and life in general is serious discussion and discourse, which, one hopes, leads to reasoned arguments and debate. Unfortunately, argument and debate almost inevitably lead to the use of flawed reasoning and rhetorical errors. Many of these errors are considered to be logical fallacies. There are way too many logical fallacies to attempt to introduce them all here, but we will discuss a few of the common ones. I'll just list them. We're going to go through them one by one. One is called the causal or sometimes false cause fallacy. There's one called the red herring fallacy, the straw man fallacy, the slippery slope fallacy, the false dichotomy fallacy, the ad hominem fallacy, the appeal to authority fallacy, the circular reasoning fallacy, the confirmation bias fallacy. Let's talk about these one at a time, just briefly. Start with the causal or false cause fallacy. This fallacy establishes a false cause-effect relationship. Morty says, "That drink you gave me must really be a love potion." Rick says, "Why do you say that, Morty?" Morty says, "Jessica never noticed me until I drank the potion, and now she says she loves me." What makes this a causal fallacy? Think about it. Morty made the unfounded claim that Jessica falling in love with him was caused by the potion. There's no supporting evidence. It's just something he said. The red herring fallacy. This fallacy brings something into the argument to distract from the original topic. Some people call this type of argument a smokescreen. Marge says, "It's all my fault that Bart turned out this way." Homer, "Well, you always did let Bart wear a bathing suit instead of underwear, so it is your fault." What makes this a red herring fallacy? Homer brought up a totally irrelevant fact and used it to conclude that it was Marge's fault. The straw man fallacy. This fallacy introduces a weak case or a misrepresentation and argues against that instead of the real point of contention. For example, Alex says, "Bicycle infrastructure should be expanded because cycling is sustainable transportation." The mayor says, "I disagree because cyclists run red lights and endanger pedestrians." What makes this a straw man fallacy? The mayor brings up a much weaker case, just looking at a couple of negative aspects, in order to switch the argument over to that instead of debating the original, much broader topic of infrastructure. The slippery slope fallacy. This fallacy introduces an argument that taking a minor action will lead to major and sometimes ludicrous consequences. Lois says, "Peter, please, I saw an ad for a used car that would be perfect." Peter says, "Oh no, Lois, a guy at work bought a car out of the paper, and 10 years later, bam, herpes." What makes this a slippery slope fallacy? Peter claims that some minor action, like using an ad to buy a used car, could lead to the rather ludicrous outcome of getting herpes. The false dichotomy fallacy. This fallacy occurs when someone presents an argument as if there are only two choices. Alice says, "I love cats." Bob says, "So you hate dogs?" What makes this a false dichotomy fallacy? Bob makes it seem as though there are only two choices. If you like cats, then you hate dogs. And of course, that is not the case. The ad hominem fallacy. This fallacy replaces legitimate arguments with personal attacks. Eddie says, "I'd like to tell you about my plans for improving education in our city." Mark says, "Why should we listen to Eddie? His own son flunked out of high school." What makes this an ad hominem fallacy? Instead of addressing Eddie's ideas for improving education, Mark instead resorted to personal attacks. The appeal to authority fallacy. This fallacy claims that you should believe or agree with something just because a person who is said to be an authority on the topic tells you to. Me, "What cereal should I eat?" You, "Whole grain Wheaties, that's what Michael Jordan eats." What makes this an appeal to authority fallacy? It's because you told me to eat whole grain Wheaties because you think of Michael Jordan as an authority on what to eat because he's an amazing athlete who must know all about smart eating choices. The circular reasoning fallacy. This fallacy assumes the premise of the argument is true in order to prove that it's true. It's like arguing in a circle. Beth says, "I'm athletic because I run." Sam says, "Well, what made you start running?" Beth, "Being athletic." What makes this a circular reasoning fallacy? Because Beth is basically saying that she is athletic because she is athletic. The confirmation bias fallacy. This fallacy occurs when someone is more inclined to accept a statement or idea based on preconceived ideas which may or may not have a solid basis in fact. Jackson says, "I'll read your horoscope if you believe in that sort of stuff." Allison says, "Yes, I want to know what my horoscope says. My last horoscope said that I would meet someone new and I met you." What makes this a confirmation bias fallacy? Because Allison believes that her horoscope has been right in the past, she is more likely to think that her new horoscope will be accurate. This probably makes her more likely to interpret events more favorably for her new horoscope and look hard for things to prove it correct. Just to look at them all at once, we have the causal fallacy, the red herring fallacy, the straw man fallacy, the slippery slope fallacy, the false dichotomy fallacy, the ad hominem fallacy, the appeal to authority fallacy, the circular reasoning fallacy, and the confirmation bias fallacy. We're not going into huge detail on this, but when you see a scenario, you should be able to identify which one of these fallacies best describes it.